Hello, I'm Arnel C. Costales. I'm gonna discuss about the optical radiation. And in this video, we're gonna look at the concept of light, optics, radiation, specifically about the ionizing radiation and non-ionizing radiation. So we might hear about radiation. What is radiation? Radiation is a general term that we give for any form of energy that with or within called electromagnetic spectrum. And there's many form of energy that within spectrum, going from radio waves, microwaves, infrared, visible light, ultraviolet, x-rays, all the way to gamma rays. So there's many form of radiation and energy. And what is interesting is that some form of this radiation have more energy than others. Why this a form of radiation have more energy than others? Because in every radiation they have different energy wave. The longer wavelength has less energy, while the shorter wave have the higher energy. There is a form of energy that within spectrum: radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. And what is radio waves? Radio waves emitted by radio stations bringing our favorite tunes. Radio waves are also emitted by stars and gases in the space. Radio waves. Example is the MOR, Bombo radio, and Love radio that being picked up by our radio. The next is the microwave radiation. What is microwave radiation? Microwave radiation will cook our popcorn in just a few minutes, but it also used by astronomers to learn about the structures nearby. What is infrared? Example of infrared radiation is night vision goggles pick up the infrared light emitted by our skin and object will hit in space. Infrared light help us map the stars. Also, what is visible? Visible lights our eyes detect. The visible light, fireflies, light bulbs, and stars all emit visible light. Also, ultraviolet. Ultraviolet radiation is emitted by sun and our duration, skin tones, and burns hot objects. In space, emitted UV radiation as well. In X-ray, a dentist use X-rays to image our teeth, and airport security uses them to see through your body. Hot gases in the universe emit X-rays. Lastly, what is gamma rays? Doctor use gamma rays imaging to see inside your body. The biggest gamma ray generator of all is universe. Next thing that I'm gonna discuss is about the electromagnetic radiation and electromagnetic waves. What is electromagnetic radiation? Electromagnetic radiation, this wave crosses way to spectrum from very short wave gamma rays to X-ray, ultraviolet ray, visible lights, wavelength, even longer infrared waves is the microwaves to radio waves that can measure longer in a mountain range. This is called the electromagnetic spectrum. The longer waves has a less frequency and less energy, while the shorter waves has a highest energy and the highest frequency. This spectrum is the foundation of the information age and our modern age. Your radio, remote control, text messages, television, microwaves, oven, even a doctor's X-ray, all depends on a electromagnetic spectrum. What is electromagnetic waves or EM waves? Are similar to ocean waves that are both energy wave. They transmit energy. EM waves are produced by the vibration of changed particles and have electric and magnetic properties. But unlike ocean waves requires water, EM waves travel vacuum of space at a constant speed of light. EM waves have crest and trough. Like ocean waves, the distance between the crest is the wavelength, while some EM waves length are very long and measures in meters. Many are tiny and measures in billion of a meter. This is the two crests. Their distance is called the wavelength. This wavelength measures in meters. The tiny and measures in billions is also called nanometers. The number of the crest has given point per second is called the frequency of waves, and 1 wave per second is called hertz. When the wavelength travels, it's called the frequency. So, as you're watching TV, not only there are visible light waves from the TV striking your eyes, but also radio waves transmitting in a nearby station and microwave carrying cell phone calls and texts, and waves from nearby Wi-Fi. Also, there are three adjacent portions of electromagnetic spectrum, namely the infrared, visible, and the ultraviolet. These are collectively known as optical radiation. Although infrared and ultraviolet radiations are visible to the human eye, they are considered to be optical because they share some propagation and interaction characteristic with visible. As does the rest of the electromagnetic spectrum, optical radiation obeys the laws of electromagnetics and can be described both as electromagnetic waves and as energy corpuscles. In optical radiations, covers the wavelength range from 100 nanometer to 1 millimeter of the electromagnetic spectrum. It must be considered that with regard to the range limits, they do not present a sharp separation which is compulsory for all applications. The detection of optical radiation can, for example, be measured by means of radiometric photometric, photobiological, or plant psychological measurable variables. In optical radiation relating to health is, optical radiation is a form of non-ionizing radiation and should not be confused with ionizing radiation, which is potentially much more harmful than non-ionizing radiation. In ionizing radiation, defined as radiation that carries enough energy to free electrons from atoms or molecules, thereby ionizing them. Ionizing radiation is made up of energetic subatomic particles, ions or atoms moving at high speeds, usually greater than 1% of the speed of light, and electromagnetic waves on a high energy end of the electromagnetic spectrum. It is the gamma ray, X-rays, and the higher ultraviolet part of the electromagnetic spectrum are considered ionizing. Also, in non-ionizing radiation, defined as, refers to any type of electromagnetic radiation that does not carry enough energy per quantum to ionize atoms or molecules, that is to completely remove an electron from an atom or molecules instead of producing charged ions when passing through matter. The electromagnetic radiation has sufficient energy only for excitation, the movement of an electron to a higher state. The lower ultraviolet part of the electromagnetic spectrum, and also the lower part of the spectrum below ultraviolet, including visible light, infrared, microwaves, and radio waves, are all considered non-ionizing radiation. Optical radiation may be produced by artificially sources such as UV lights, common light bulb, and radiant heaters. But the primary sources of exposure for most people is the sun. This exposure can result in negative health effect. All wavelengths across this range of this spectrum, from ultraviolet to infrared, can produce thermal injury to the surface layers of the skin, including the eye. What is an ultraviolet ray? Ultraviolet radiation is defined as the portion of electromagnetic spectrum between X-rays and visible light. It is produced by electric arc, mercury vapor lamps, and tanning lamps. There are also advantages of ultraviolet ray. There are 5. Number 1 is the natural sunlight stimulates the production of vitamin D, a vital component in the formation of healthy bones to protect the body from breaks and fractures. Number 2, the fluorescent lamps used in the treatment of neonatal jaundice and psoriasis. Number 3, UV lamps are also used in the food processing industry as a non-thermal tool for sterilizing food. Number 4, UV lights are used in pest controls. Lastly, number 5, detecting pollution or degradation of insulation in an electric device is carried out with the help of UV radiation. UV, is it harmful? Yes, because the effect is sunburn and tanning, but these are the short-term result. The long-term effect is the eye problems, immune system, and skin cancers. The exposure to UV radiation is a major risk factor for most skin cancers. Sunlight is the main source of UV rays. People who get a lot of UV exposure are at greater risk. There are 3 types of UV rays: the UVA, the UVB, and the UVC. These are the ozone. This is the UVA. UVB. UVB. UVA has a wavelength of 320 to 400 nanometer, not absorbed by the ozone layer. UVA is the most commonly encountered type of UVA light. UVA exposure has an initial pigment darkening effect followed by erythema if the exposure is excessive. UVA is needed by humans for synthesis of vitamin D. However, overexposure to UVA has been associated with toughening of the skin, suppression of the immune system, and cataract formation. UVA light is often called the black light. In UVB has a wavelength 290 to 320 nanometer, mostly absorbed by the ozone layer, but some does reach the Earth's surface. UVB has a wavelength of 290 to 300 nanometer, mostly absorbed by the ozone layer, but some does reach the Earth's surface. UVB rays have a lower energy level and a longer wavelength than UVC. The UVB mostly absorbed by the ozone layer because it has a less wavelength than the UVA. Also, the UVC wavelength has a 100 to 900 nanometer, completely absorbed by the ozone layer and atmosphere. UVC rays do not reach the Earth's surface because of the ozone layer. Both UVA and UVB rays can damage skin and cause skin cancer.